Moving back into it, multiplying and dividing fractions. So this is a second, I guess, second out of 3 video for section 5. It's a fairly complex section. Multiplying and dividing fractions. There's more than one way to do this. The standard algorithm is if you're multiplying 2 fractions together, you multiply the numerator times the numerator. 2 times 9 is 18. The denominator times the denominator. 3 times 10 is 30. And then we reduce. So we say, what can we divide or what can we factor out of 18 and 30? We can divide them both by 6, and we would get 3/5, because 6 divided by 6 is 1. And so the 6's divide to 1, and we're left with 3/5. That's kind of the standard algorithm. One thing to note for multiplying and dividing with fractions, you don't need to have common denominators, because we're asking kind of a weird question. What we're asking is, what is 2/3 of 9/10? So we're saying if we took 9/10 and broke it into thirds, how much would 2 of those thirds be? It would end up being 3/5. And you could draw out pictures, and I'm not going to go through that right now, but you don't need common denominators because we're asking a different type of question. We're not combining these 2 fractions together. We're saying, what is 2/3 of 9/10? So that's, okay, well, I'm going to move on though. So that's our standard algorithm. There is another way. 2/3 times 9/10. Another way that you could do this is, instead of multiplying first and then dividing or reducing, we could reduce first and then multiply. And this is what's called cross-reducing or cross-simplifying. What we're looking at is top and bottom, and it doesn't have to be diagonally, but top and bottom. Is there anything we can reduce? Or are there any 2 numbers that we can factor out of both of them? I'll show you what I mean. For like the 2 and the 10 here. 2 and 10 have a common factor of 2. I can divide them both by 2. If I do that, 2 divided by 2 is 1, 10 divided by 2 is 5. But look at the 3 and the 9. The 3 and the 9 have a common factor of 3. I can divide them both by 3. 3 divided by 3 is 1, 9 divided by 3 is 3. Now that I've eliminated or factored out those greatest common factors, I can multiply. 1 times 3 is 3, 1 times 5 is 5. The benefit of doing this is we start with smaller numbers. We don't create bigger numbers to work with. 18 and 30 is we factor things out first and cancel them or divide them to 1. Then we multiply. I'm going to use that method more often than not because it's just faster. But let's look at this problem. So we got 12a squared times 5x to the third. And 3x squared times 4a to the fourth. So if we do it the standard algorithm, multiply the numerator times the numerator, denominator times the denominator, 12a squared times 5x cubed, 3x squared times 4a to the fourth, we'd end up with this. 60a squared x cubed, 12a to the fourth x squared. X squared, a to the fourth are different, so we can't combine them together. 2 times 4 is 12. And now we can reduce it. And we can say, okay, how can I reduce with these numbers here? I can divide both 60 and 12 by 12. 12 divided by 12 is 1. 60 divided by 12 is 5. So I could reduce that. When you're dividing with when you're dividing with exponents, remember that we're basically saying, what can I cancel away from the numerator? What can I cancel away from the denominator? If there are 2 a's in the numerator and 4 a's in the denominator, a divided by a is 1. A divided by a is 1. You know what? I'll finish this up and I'll move over to the document camera and show that a little bit better. But this will be our reduced version. The other method, which is canceling first, is this. If we have 12a squared, so we have that original problem again, and I look top and bottom. I say, what can I divide away? One thing, and there's more than one, but one thing I can divide away right away that I see is this 12 and the 4. I can do 12 and 4. I can divide both of those by 4. If I do that, 4 divided by 4 is 1. 12 divided by 4 is 3. So now if I multiply, and some of you might see other things, but now if I multiply, I'd have 3a squared times 5x to the third, and I have 3x squared times a to the fourth. But get this. We can take it further though. I've got these 3's here. 3 over 3. Well, there's another one. 3 divided by 3, and so that's 1 for both of those. And the 5 I'm kind of stuck with. If I look at the a's, I've got 2 a's in the numerator and 4 a's in the denominator. So if I take those 2 a's away in the numerator, and take 2a's away from the denominator, I'd be left with 2a's in the denominator. With the x's, same idea. I've got 2x's in the denominator, 3x's in the numerator. If I take 2x's away from the denominator and 2x's away from the numerator, I'll have 1x left over. It will look like this. Just saying this out loud, it feels very complicated. And so I am going to look at the document camera just to talk about, very briefly, the x's and how we were able to cancel those and whatnot. And if you've got this, great. If not, then here's hopefully a little bit better explanation. Hopefully we can see that 60 and 12, we can divide both of those by 12 and get 5. 12 divided by 12, 6 divided by 12. The a's and the x's, though, I'm going to expand this out. So I'm going to say that's a times a, x times x times x. And we've got 4 a's here. And I've got, 2 x's down there. Okay, so I've just expanded these exponents. If we go from there, a divided by a is 1. Doesn't matter what a is, a divided by a is 1. A divided by a is 1. That's it. That's all I've got. All right, x's. X divided by x is 1. X divided by x is 1. So really, I've got 1 times 1. And then I've got this x in the numerator here. I've got 2 a's in the denominator there that I wasn't able to do anything with, times 1 times 1. Well, when you're multiplying, times 1 doesn't really do anything. We're still left with whatever we have. Same thing over here. So this is what I'm left with. That's x over a squared. So that's the expanded version. The other way to think about it is I'm going to take 2 a's away from the numerator, 2 a's away from the denominator. I'd be left with 2 a's left over here. Same thing with the x's. I can take 2 x's from the numerator, 2 x's from the denominator. I'd be left with just 1 x there. Hopefully that was at least a little bit better of an explanation. Please email me if you're still stuck on those. Okay, so multiplication. Try these two on your own. Try and simplify the first one, and then for the second one here, multiply and simplify the second one. I'm assuming you paused it. I'm assuming you tried it on your own. The first one looks like this, and I'll let you pause it and look through it in detail. The second one looks like this. I'll do a follow-up video and go through those a little bit slower, but those are the solutions. If you didn't get those, or if you're lost on where I got some of those numbers from, I'll do a follow-up video after this. Dividing fractions. Dividing fractions is the same as multiplying with one extra step. We're not going to get into why we do this. That's a different class, a different lesson. But the algorithm or the method that most people use, or we typically use to divide with fractions, is to take the second fraction and flip it over. Take what's called the reciprocal of the second fraction. And instead of dividing, then we multiply. So we're going to do the first fraction times the reciprocal of the second fraction. We take the second fraction and flip it over, take the reciprocal. Then we multiply. Now, before we multiply, I'm going to see what I can factor from this. So the 4x squared minus 36, I know I can divide both of those by 4. The x minus 3 I'm kind of stuck with. The 12 I'm stuck with. The 4x plus 12, I can divide both those by 4. So I get this. Now I'm looking at what can I cancel. Well, I've got this 4 and the 4, so the 4's would cancel away. This x squared minus 9 happens to be a difference of perfect squares. X squared is x times x, 9 is 3 times 3. So that factors a little bit further to x plus 3 and x minus 3. Again, the 4's cancel, the x minus 3's cancel, the x plus 3's cancel, and that almost covers everything. All we're left with is 12. That's the simplified version. 12 is the simplified version of this division. There we go. I'm going to stop here and do a third video because I just think it needs to be a break. And we'll do adding and subtracting polynomials in a third video.